Hello, Subhanallah. Assalamu alaikum. Hello, Saikul.
হ্যালো, আসসালামু আলাইকুম।
শুনতে পাচ্ছি তো? Okay. Event. Just a moment. Okay, let's start. Okay, who else is joining today? Okay, আজকে যে টপিক সেটা হচ্ছে কোড সিম্বল এন্ড নেমস। Code symbols and names are very important topic in PLC programming. Not only it's actually standardize the whole project, it also helps all the stakeholders like project managers and then sales teams to the you know drafting man and then instrumentation engineer, electrical engineer, and then finally the software engineers who does the coding of the PLC. So it actually standardize the project variables like name of the instrument, coding and tag and how they function in one factory or to all across all the departments. So there are actually few types of diagram used in instrumentation, electrical and in PLC programming, especially in the field. It involves combination of electrical instrumentation as well as some functional variables. PFD, actually I have given some link what they are in the GitHub. PFD here. PFD is actually process flow diagram. Process flow diagram. It is kind of overview of the whole plant. If it is a very big plant, for the top management, how to understand in one sheet, one paper, they want to understand the whole plant. So that's the PFD does. PFD actually is a kind of draw the miniature version of the whole plant, but in summary, overview. And process instrument diagram is kind of detail. It's like a more detail than PFD, but it is still not as much detail required for mechanical engineer or piping engineer, because there is not enough information like length and size and where the instruments to be installed and what is the distance gap between lands and pipes. Those details are not mentioned, but it is quite more, I mean, enough for instrumentation and the process engineers to understand the process. Loop diagram is a kind of loop sheet we call, but it's also kind of drawing where the connection is mentioned. One electrical where the signals are going from where to where, like it's a one panel to another panel, and then field in which instrument. Those loops are actually drawn in this loop diagram. And functional diagram is like the instrument diagram plus some functional thing is mentioned additionally. So in this instrumentation to be standard, some names and symbols to be standardized. The valve should be drawn in everywhere in the same manner to understand that this is the valve and what kind of valve, and for valve what should be the tag name. And those identification letters is actually uh, given by one standard organization, ISA organization. They have this kind of documents, instrumentation, symbol, and identification. I have some here more downloadable version. I think this one is downloadable. You can download this file. So it's a ISA 5.1 2019 last version. So this book actually defines all the detail about the plant identification. This is one of the identification letter. For example, for the level measurement, or level sensor, or level related any instrument, the tag name will start from L, and for flow it is F, for voltage it is E, and the analyzer, any kind of analyzer will start with the A, and pressure is it will start with the P. So these are standardized. So once this is accepted in any project, that we will follow this guideline, and wherever our instruments and tags to be used, we will use this nomenclature. So in that way, engineers across the department, they will understand, they will not have any misunderstanding, and why some instrument names like that way. So from the letter, from the tag name itself, they will have a lot of information. This document has a lot of details, and also it has some of the instrument device and symbols in the drawing. If it is a kind of binary instrument, then it should be rounded, and if it is shared instrument, shared means shared display and shared control. So this kind of instrument to be marked this way. For example, the pressure sensor is connected to PLC, but the pressure value is displayed on HMI. So in that case, that pressure sensor symbol will be marked like this. But if something is only connected with the PLC but not any display device, then without this square. This dotted means actually behind the panel or inside the panel, not in front of the panel. If it is clean, line, that means it is in front of the panel. It's in the front side. So this is located in front of secondary or local panel. This double line, and this is the main panel. Single line is the main panel, and dotted is always behind the panel or inside the panel. And then there we have some symbol for other devices like mathematical and or kind of symbol, but this is rarely used. This is the symbol for the measurement variable, where to put the tag. This is where the tag is mentioned inside the circle, but if the circle is small and tag is big, then actually one part of the circle is left unconnected, and tag goes across the circle. It's not shown here, should be somewhere. So whatever used in instrument in industry and factory line, almost every symbol is available in this document or near approximate. So this is, I have to go through next. One example I want to show. Okay, let's go here. So this is like first letter, and 2 letters we can actually choose from here. And then instrument line also. Now lines also has meaning. If it is straight line, without dotted or in any this kind of symbol is there, that means it's a flow line. And mechanical line is linked with this dotted circle. Data link, like computer and communication cable, is linked through this one. Circle and then line. Data link, this is also dot. Independent system. Radio is marked with this one. Okay, I have gone through this one. It's the same thing. Discrete instrument shared with this square mark. It is shared. Computer function is the hexagon. This one. And logic is this, a diamond mark. Here is the different kind of control valve and damper symbol. This is general valve symbol. This is rotary valve, and this is diaphragm, globe valve. So this is usually used in instrument drawing, PNID drawing. Actuator symbol, the diaphragm actuator, electric actuator, solenoid valve actuator. This is actually name is used. S for solenoid, M for motorized, and P is used here for the positioner, analog positioner. This is not visible quite. All right. Okay, in some cases actually more detail is mentioned, like fail to open. If the valve is fail to open type of valve, like fail to open means what? It has open feedback. The valve has open feedback sensor installed. That means that valve can give feedback to the PLC whether the valve is failed or not. The PLC can actually determine. So the open feedback is available for this one. This one is locked sensor is possible for this valve. So this is more detail for the valve single symbol. And there is a level measurement symbol available. So the different kind of level measurement is possible. Radar and then ultrasonic, laser, tape and float, capacitive, bubbler, then hydrostatic, displacer. So all has different kind of symbol. And flow measurement is very complex because in the market there are tens of dozens of flow measurement technology, and each is defined in different way. There is also equipment symbol, like this is motor or mixer. Conveyor belt is symbol is this. Jacket vessel, where the vessel is heated or cooled by the jacket. And this is motor driven fan, centrifugal pump, pressure vessels. And company also sometimes make it more representable, so they make it colorful and nice to represent in their HMI sometimes based on this equipment and symbol. But in drawing actually they are look like this, is simple in drawing. But in HMI and SCADA usually they want more presentable form. And what is LLL, HLL, and this is kind of HMI. We actually sometimes create alarm. It's like low, low, low. That means very, very low level. And this combination high, high, and low, low. And here is in instrument also we use this kind of presentation. Like here, if you see this LAH, LAL, this is actually level alarm high and level alarm low. So this two computer, this is shared information. So this means you see the square mark, that means this information is shared between PLC and HMI. So this information PLC also has, as well as HMI also has this information. But this one is local. This rounded instrument symbol, these are installed locally on the tank. And then from local here, through the dotted line, it goes to the PLC. And then it is shared with the HMI. And these are actually mainly used variable in PLC. I have just mentioned here few because these are most repeated names in PLC programming, like flow rate, sorry, level, pressure, quality, speed, temperature. And the emergency or safety instruments code is like high level, extreme high level, HH, low level, and extreme low level. These are actually based on process logic. It can trigger some kind of alarm, and then it can actually stop some of the process things like valves or pumps. And structure of the instrument code, if you see here, one of them may be LZT and then 101. So, and then TL103, LT103. So this first, the alphabetic name is indicating the type of instrument, and then second, numeric values are actually the number of that instrument representing, location of those instruments. So it's actually to identify them, their location, and kind of instrument. So here XX is the identity of the process. It has one example here. It's a process. 10 is the tank numbers, let's say, and then T is for tank, and then tag number is just identification. Another A is a letter code containing two or more letters used to identify the instrument function. So in this case, it is an instrument function here. LZT, TL, LI. These are instrument function, but if there is unit involved, then unit name is mentioned just before this number. For example, here, so 10 is the unit number. That means the whole tank is identified as the 10 number of tank. So where the instrument is installed is a tank number 10. And then it comes PLC variable names. In PLC, mostly we have some logics. It is actually logic, that's why we call programmable logic. And if we calculate those logics, theoretically it is like A is equal to B into C, but if we don't give proper name, it's very difficult for programmer to understand. So what programmers do is kind of they give the variables proper name to understand, like weekly pay equal to hours worked multiplied by hourly pay rate, this kind of thing. So there is some guideline for PLC naming also. Hmm. Just like in instrumentation, symbols and codes are used for the standardization. PLC also, some of them are standardized, but this is also company to company. Some company use different convention, and other is based on their previous experience, how they are working, and what they prefer. Maybe it depends also on the senior engineer who is actually convincing that they follow his way of working. So usually motor starter like MS, control relay CR or K, solenoid valve SV, then switch SW, push button PB, and if it is HMI push button, then H, then PB. Master control relay, the limit switch is LS. So this is prefix, and then we can name underscore, maybe number 5 switch, those kind of thing. And we try to match this process tag with the process instrument tag name, like process flow transmitter FT. It is similar to the process instrument code, valve HV or FV. Then limit switch LSL or LSH, low and high. FIC is a instrument control, pressure instrument control. And then push button HS and HIS. Proximity switch is Z, and then S switch. Then motor starter M, PT for pressure transmitter. Now if we want to Cycle, are you getting?
Yes, I am getting.
We will do some coding here related to valve only, but we will try to use little bit complex like with feedback and maybe two commands, and also we'll try to use HMI to start open and close. Okay, so other day we have done this programming to open and close the valve, and then we will do another kind of valve with feedback and see how our ChatGPT is responding, because we have taught ChatGPT about the valve, so it must respond uh, the relevant code. This is be valve 2. In as per the open PLC, the standard, the function block also has standard how it should be named and so forth. We have actually, let's just open that one. There is one standard. Why you need to standardize PLC variable naming convention. Okay, PLC guidelines, English, this one I guess. Yes. So it has actually all the variable name, how it is standardized by PLC Open, which is actually kind of creating PLC programming standard IEC 61131-3. So if it is array, then it will start with the A, structure ST, for program PRG, Boolean X or B. So this is the standard, and then we have local scope L, G for global, POU parameter, P temporary variable, TMP. I guess it has some thing for block also. Block is not given here, but anyway, it can be standardized like PRG and then the name of the valve, like valve 2, or maybe it's a valve with open feedback, this kind of name, and then static. Let's ask ChatGPT to create the program. We open here. We you are a PLC programmer, expert C programmer. Want to you to write code for the following. So it's like setting the ChatGPT to expert mode. So we are expecting high level, high quality code from the ChatGPT. It's like prompt engineering to make sure I will be able to assist you in writing appropriate PLC code. So let's just give him the problem. We have a valve with open feedback. We want to control the valve from PLC control panel. Push buttons, open PV and close PV, as well as from HMI by open and open push button, and close button. It failed. I save failed to open alarm for HMI, and also turn on buzzer and fail to open alarm is triggered. Give us the code is ST code program. Let's try to get the code for the PLC. So here is given the program description, how it is working. Open valve method is actually function, is called when the open button is pressed. It sets the open button signal to true to simulate the valve opening, and waits for open feedback signal to indicate that valve is open. If the open feedback signal does not turn on within specified delay, indicating a fail to open condition, fail to open alarm is triggered and buzzer is turned on. And close valve method is called when the close button is pressed. It sets the close button signal to true to simulate the valve closing. Wait for appropriate delay before resetting the close button. Main cycle method is the main control loop. So this main program where the other functions are called, but it's actually has given pretty neat description to the code how it's working. So this is main cycle, and when the open button is pressed, this open valve function is called. When close button is pressed, close valve function is called, and if not fail to open alarm, buzzer is turned off. Fail to open alarm is set to false. Why this is? Okay, we'll come to this is not right. Okay, we'll make it right. Let's do the programming. So here is the program. We have to actually copy this part or cut this part and paste inside this, and then delete this one. We don't need it. We also need this part here. Open delay 1 second, close delay 1 second, and fail to open delay 5 second. Okay, and then method, this method valve open is going to be different function. We can create a function. You can copy this into here, and then call this inside here. Okay, and then delay, open delay. This is also wrong because this is not the PLC instruction. It has to be a timer. So this is not correct. If not, open PLC feedback. So this is checking the feedback. So this feedback is available here, dot feedback, and then fail to open alarm. Okay, fail to open alarm also available inside this program. we can link it here. Again, delay failed to open delay. This is also wrong. This is not available. We can actually mark, kind of comment it. If we don't need, we can comment it, and then bazaar. So this bazaar is also declared inside this program. I guess somewhere it's not available here. So this bazaar is came where? It should be here in the main fail to alarm के बाद. It's here. This one. So bazaar is also available inside this program. And open button is this one. What this program is doing, when we're calling this function open valve, it is actually giving the command to open. For the open command, we need true, like 24 volt, signal. So we are turning on the relay open command, and then we are waiting for the feedback. So this feedback is actually should come from the valve. So if valve signal is not there, then actually we can raise alarm that okay, this valve is failed to open because we didn't receive the open feedback, and then we actually turn on the buzzer for the operator to know that there is something wrong. The valve is not open, even we try to open by pressing the button. So if valve is not open or it is open, finally we actually reset the open button. It's like button signal. If it is HMI button, so once we press the button, it is actually on. After, even if operator remove the finger from the button, it has to be reset, right? So that's it is done here. Reset the open button. And similarly, it should be done for the close valve function. So this is another function, close valve. We can copy here. We are going to remove from here. And create another function like close valve function type. And this is easy for close valve because it has no feedback. Once the close command is given, it is closed. So this is some function available, the variable declared inside this. So we can link this variable, and then this is also wrong. We don't have, we can actually give delay, but this delay instruction is not right. So this is close method, close function. What else is there? Main cycle. Okay, so main cycle is where it's supposed to be inside this. So that code should be inside here. But we will do one thing. We will modify. We'll copy this one and we'll call it here inside the main. This is PLC main program. And then it goes here. So now we can do actually this part of the code. We can copy from here and put it here. So what will happen, it will come here. If open button is pressed, then call this function. If close button is pressed, then call this function, close valve. And if not fail to open alarm, then buzzer reset, and then reset fail to open alarm. Fail to open alarm is reset in every scan, so this is not right location to actually say it reset. We can actually reset at the beginning. Fail to at the beginning, we have to put here. Fail to open alarm. We reset at the beginning of scan, and then when this valve is, this program is scanned, if during this scanning it found that this condition is true, it will actually set fail to open alarm every time. But if this line is pasted here at the end, even though there is alarm, the alarm will get reset at the end, because last time I said the program scan from top to bottom. So when it reaches the bottom, it will actually reset the code, reset the alarm, this one. So it's better to reset any variable that will need to be reset or set to initial stage. We have to use at the beginning, and then we do the programming. So if as per the logic it gets set, it's good. So this is one kind of valve programming. Now let's try to see if we have different valve with both open feedback and closed feedback. So what will happen, this part of the code is for the feedback to check whether it is fail to open or fail to close. So this part of the code also will be included here in the closed valve. So let's see if it is doing that thing automatically. This part, if I just ask ChatGPT this, line of code should be at the beginning, and now let's see whether it is correcting itself or not. You see, it has put that line at the beginning in the main cycle. So now it is matching with our program. If not fail to open alarm, then buzzer reset. So this is good. It's actually perfectly what we did. If it is not, you see, exactly matching with our requirement. By placing this at the beginning of the main cycle, it ensures the alarm is reset before any other logic is executed. So this is what the explanation is also given. So it understood perfectly why we want that line to be at the beginning. It's very clever that it knows the reason why we put this code at the beginning. So let's we do the same thing with little modification. We have a valve with open feedback and closed feedback. We want to control the valve from the PLC control panel push buttons, namely let's say open PB and close PB. Okay, we also want to control the valve from HMI by open button and close button. Create fail to open alarm for HMI and also turn on buzzer when fail to alarm is triggered. Fail to alarm and fail to close alarm for HMI and also turn on buzzer when fail alarm is triggered. Failed to open or close alarm is triggered. Write the code st code for the code sys program. Now we also we need 5-second delay for fail to open alarm to trigger and 7 seconds for fail to close alarm to trigger. Operator can reset the buzzer by acknowledge the alarm at the HMI. Okay, now operator can reset the button by acknowledging the alarm at the HMI screen. Let's see how it's doing. Okay, so it has created the logic and also given the description here. We will need to replace the placeholder comment, set any necessary output for valve control with actual PLC logic. So yes, this is just code without PLC hardware, output address. So it has given that notification note. Make sure to configure the input output variable according to your PLC hardware setup. So here valve control from both PLC control panel push buttons and the HMI buttons. It monitors the open close feedback from valve and triggers the fail to open or close alarms after the specified delay times. Buzzer is turned on when the alarms are triggered. Operator can acknowledge the alarm at the HMI screen to reset them. Remember to adapt and customize this code. Of course, we need to adapt this. So let's see if we can use it. This time it has more code, it seems like. we can create another POU PRG valve with open and close feedback PRG. Okay, we need this to be here. We don't need this. Okay, we need this code here. This is variable declaration part. This is the main program. Okay, we want main program to be here, but without name. Main program and method. This time the code is little different. Okay, main open PB or open button. So this is how we have actually described the problem. Open PB, I have given this name for push button in the control panel, and for the HMI open button and close button. So it perfectly actually using that same name, open button for a control panel, and this is HMI button. One of them is true, then set the valve open. So what we can do here, we simply can call this block what we have done previously. We have done this program for the open valve, right? We can simply call that valve and it should work perfectly. But the thing is that variable we have used are from here, open button and close button. So this will not work. Okay, and then if close button, push button and close button, this is to close the valve. In this case also we cannot call this block, because inside this block we have used the variable from this block, not this block. So if we can use the function, we have to actually reference the variable correctly, otherwise it will not work. So this is perfectly this is a one use case that why a function and function block need to be standardized with the inputs and outputs, because we have not standardized the function and we are directly using other function blocks variable or program block variable. It is not a standard function, it is just a function with variable linked to other blocks. A standard function will have a variable with the input and some output. Calculation is done by using the input variable value, and then output result is sent to the output variable. We will do in the next session how we can standardize the block function and program, and how we can use the same valve function in multiple program block. Any kind of valve, whether it is without function feedback, with feedback, open, only open feedback, only closed feedback, any kind of valve, if it is called, it should work perfectly fine. So that's in the next session I will prepare on session. Now this will make us little weird, because in this case we need to kind of create different function. We cannot use this function, because it is used for other function block. And if feedback, open feedback is not there, then it will actually trigger a timer. This is good. This time it has actually taken a proper timer, open alarm timer, on delay timer. T on is for on delay timer, and it is also defining the delay time. Okay, this variable is not defined, but it is assigned. Okay, it's there. Okay, so this is wrong. This should be var underscore constant and var. Why it's not taking? Oh, underscore is not there. Okay. Something is not right. Variable type was not given, so ChatGPT is actually not doing right, even though it is expert PLC programmer. Now this timer will run perfectly fine, and now when it is feedback is not there, timer will run, and when there is feedback, it will reset the timer, close the alarm. Similarly, after it is executed, when the timer is running, in case there is alarm means the timer is actually expired. It is running more than 5 seconds. Then open alarm is generated, buzzer also started. Similarly, for close alarm, Q, this is open alarm, this is close alarm. Okay, there is two code. This is for open, this is for close. There's a similar close alarm trigger, but it's checking timer. This is open timer, close timer. And then if there is a alarm and buzzer is it's on, then operator can acknowledge by setting some acknowledging the button, or somewhere there should be some button to acknowledge the alarm in HMI, or in the control panel, PLC panel also there should be some reset button like stop the buzzer. So if that is pressed, then open alarm and close, and whatever the alarm is there, it should get reset. So that's how the alarm gets reset. I think we can stop today. Time is over. Next day we will have standard blocks, standard function and function blocks and programs, so forth. Soeb, how are you?
I'm fine.
I cannot hear.
Hello?
सुनाई नहीं दे रहा है, শুনতে
হ্যাঁ
পাচ্ছি না। হ্যালো,
হ্যাঁ শুনতে পাচ্ছেন?
হ্যাঁ এবার শুনতে পাচ্ছি।
প্রবলেম নেটওয়ার্ক প্রবলেম হচ্ছে একটু। তো দেখতে পাচ্ছি
কিছু
এখন।
কিছু বুঝতে পারলে?
হ্যাঁ এমনি প্রবলেম তো আছে, কি দেখছি এখন আস্তে আস্তে আরো ক্লিয়ার করে নেব। প্রথম পিএলসিটাকে আরো দেখবো অনেক, এই থেকে ওয়েবসাইট থেকে বলতে
আমি
দেখে
কিছু
বুঝতে।
আমি কিছু কিছু লিংক এখানে রেখেছি, ফলো করতে পারো। ইন্টারনেট তো এখন lot of things are free. YouTube is free. If anyone can learn, he'll learn from anywhere. But practice is more important. Okay, thank you. We close today. Saikul, বুঝতে পারলি আজকে?
হ্যাঁ, বুঝতে পারছি।
আচ্ছা, ঠিক আছে। Next Tuesday. Okay, bye. Assalamu alaikum.
নমস্কার।